In September 2023, an expedition from the Schmidt Ocean Institute's Deep Sea Exploration Program, operating aboard the research vessel Falkor 2 in the waters of the western Indian Ocean, southeast of Reunion Island and north of the Kerguelen Islands, deployed the ROV Sebastian on a geological exploration dive to a depth of 3,800 meters in a region of the seafloor that ocean current models identified as an accumulation zone of sediments transported by bottom currents from the Southern Ocean. The mission's primary objective was to document the bottom-dwelling invertebrate fauna and collect sediment samples for geochemical analysis. However, during the fourth hour of the dive, as the Sebastian moved across the sediment following the contour of a basalt rock formation, the vehicle's cameras captured something in the sediment that no member of the team expected to find at that depth in that region of the Indian Ocean. Fragments of metallic structure and what the ROV pilot identified as part of an aircraft landing gear, partially buried in the sediment but perfectly recognizable by the characteristic shape of the shock absorbers and wheel mounts. What the ROV had found on the bottom of the Indian Ocean could be the remains of an aircraft that disappeared during one of the many flights that vanished without a trace over that ocean in the second half of the 20th century. Like, subscribe, and share. Let's begin. The Indian Ocean is the scene of several of the most well-known aviation mysteries in modern history. The most famous and recent is the disappearance of Malaysia Airlines flight MH370, the Boeing 777-200ER that vanished on March 8, 2014, during a flight from Kuala Lumpur to Beijing with 239 people on board. The search for MH370 became the most expensive in aviation history, with total expenditures exceeding $160 million for searches conducted by Australia, Malaysia, and China. Although several fragments of the aircraft have been found on beaches in the western Indian Ocean, the main wreckage has never been located despite multiple sonar search campaigns across a search area of more than 120,000 square kilometers in the southern Indian Ocean. The search for MH370 was the first to map in detail extensive regions of the Indian Ocean floor that were previously virtually unknown, revealing a topography of underwater volcanoes, oceanic mountain ranges, and depressions that previous maps only showed in a very approximate way. But MH370 is not the only aircraft to have disappeared over the Indian Ocean. The history of 20th century aviation records several flights lost without a trace over that ocean, especially during periods of peak military and civil aviation activity in the 1950s, 60s, and 70s. Long-range military reconnaissance flights operated by NATO and Allied forces over the Indian Ocean during the Cold War, commercial air routes between Australia and Europe that crossed the Indian Ocean before the era of long-range aircraft that could make those routes with fewer stops, and military transport flights that supplied Allied bases in the Indian Ocean and Southeast Asia during the Vietnam War, are all categories of flights that were lost without their wreckage ever being found. The landing gear found by the Sebastian was thoroughly documented with the vehicle's high-resolution cameras during more than 2 hours of exploration of the surrounding area. The metal fragments were scattered in a radius of approximately 200 meters around the point of greatest concentration, with a dispersion pattern that the team's aeronautical engineers would later describe as consistent with the impact of an aircraft that reached the water on a relatively flat trajectory, as if it had attempted an emergency water landing rather than plummeting into the water. This impact pattern produces a wider and less concentrated dispersion of fragments than a vertical impact, and the distribution of the debris on the seabed was consistent with this hypothesis. Several fragments of what appeared to be wing structure, identifiable by the characteristic cross-section of aluminum wing spars, and sizable pieces of fuselage were documented and photographed from multiple angles. Identifying the aircraft required determining its type and, if possible, its registration or serial number. Aeronautical engineers analyzing the images of the Sebastian identified the landing gear as a tricycle type with a nose wheel, which ruled out most propeller-driven aircraft from World War II and the immediate post-war period, which generally used tailwheel landing gear. The scale of the components, estimated by comparing them with the surrounding geological features and the ROV's own instruments whose dimensions are known, indicated a medium to large aircraft, consistent with a long-range transport or reconnaissance aircraft rather than a light combat aircraft. The construction material, visually identified as aluminum based on the type of corrosion observed, was consistent with aviation from the second half of the 20th century. The possibility that the debris belonged to MH370 was the first hypothesis considered by the team given that the search had generated the most extensive knowledge available about the regions of the Indian Ocean where aircraft debris might be found. However, the coordinates of the Sebastian's discovery were more than 3,000 kilometers north of the main MH370 search area, which was concentrated in the southern Indian Ocean along the seventh arc of the route calculated from Inmarsat's satellite data. This distance made it extremely unlikely that the debris corresponded to the Malaysia Airlines Boeing 777. The team's researchers contacted the Australian Transport Safety Bureau, the Australian agency that coordinated the MH370 search, and the Bureau's experts confirmed that the documented debris was not consistent with the structural components of a Boeing 777 or with the known characteristics of the missing flight. A search of aviation records to identify aircraft that disappeared in the western Indian Ocean region where the discovery was made revealed several possible candidates. Records from the International Civil Aviation Organization, ICAO, and the aviation accident files of the U.S. National Transportation Safety Board listed several flights that disappeared over the Indian Ocean between 1955 and 1985. One of the cases that garnered the most attention was the disappearance of Air India Flight 101, a Boeing 707 that vanished over the Indian Ocean in June 1966 during a flight from Bombay to Nairobi with 106 passengers and crew, and whose wreckage was never found. The estimated dimensions of the fragments found by the sub-bastion were consistent with a Boeing 707, although that consistency was not sufficient for a definitive identification. Like, subscribe and share. The serial numbers on aviation components are the most reliable key to identifying a specific aircraft, as each major structural component of a commercial or military aircraft has a unique serial number engraved on it that can be traced back to the manufacturer's records. The sub-bastion lacked the means to physically recover any fragments from the seabed, but its ultra-high-resolution cameras imaged multiple fragments in search of visible identifying marks. On one of the fuselage fragments, the cameras captured what appeared to be numbers and letters etched into the metal, although corrosion from decades of immersion in the Indian Ocean's salt water and the available lighting angle made it impossible to read these markings with certainty from the available images. The analysis of images of the Sebastian using digital image enhancement techniques was commissioned to a specialized laboratory at the University of California, San Diego. Technicians at the laboratory applied contrast enhancement and noise filtering algorithms to the images of the potential identification markings and reported that they could distinguish with some confidence a partial sequence of characters that included what appeared to be a letter followed by several digits. This partial sequence was compared to serial numbering formats used by major commercial and military aircraft manufacturers from the period 1955-1985, including Boeing, Douglas, Lockheed, and the Soviet manufacturers Tupolev and Ilyushin. The results of the comparative analysis were preliminary and inconclusive at the time the information was gathered, but the researchers expressed cautious optimism about the possibility of ultimately identifying the aircraft with a second expedition equipped with sampling capabilities. The bottom of the Indian Ocean holds the secrets of decades of aviation in one of the world's least explored oceans. The planes that have disappeared over the Indian Ocean represent not only technical aviation mysteries, but, in many cases, human tragedies whose families have spent decades waiting for answers about the fate of their loved ones. Every fragment that the ROV documents in the ocean sediment brings us a little closer to that answer, even though the path between discovery and final identification is long, technically demanding, and emotionally charged with the stories of the people who were traveling on those planes. The history of searching for missing aircraft over the oceans is a specialized discipline within aviation accident investigation that has evolved enormously thanks to the development of underwater exploration technology. Before the era of autonomous underwater vehicles and high-resolution sonar, searching for sunken aircraft in deep water was virtually impossible except under exceptional circumstances. TWA Flight 800, a Boeing 747 that disintegrated off the coast of New York in July 1996, was almost entirely recovered from the Atlantic floor at a depth of 42 meters because the area was accessible to divers with conventional equipment and the impact position was accurately determined. Air France Flight 447, an Airbus A330 that crashed into the tropical Atlantic in June 2009, took almost 2 years to locate despite the search area being relatively well known, and was finally found at a depth of 3,900 meters thanks to the deployment of autonomous underwater vehicles equipped with side-scan sonar. These experiences showed that recovering aircraft in deep water is possible with the available technology, but it requires resources, time, and a sufficiently limited search area to be feasible. The emotional impact of finding aircraft debris in the Indian Ocean transcends the technical aspects of the investigation. Every plane that disappears over the world's oceans represents human lives that ended abruptly and inexplicably, and families who have lived for decades with the uncertainty of not knowing exactly what happened or where the remains of their loved ones rest. In the case of Flight MH370, whose search generated the greatest international media attention of any aircraft disappearance in history, the families of the 239 people on board have been in a state of mourning for more than 10 years, their grief interrupted by the lack of definitive answers. If the debris found by the sub-bastion corresponds to any of the missing flights over the Indian Ocean, the identification of those remains would have a human dimension that the technical investigation cannot ignore. International protocols for the investigation of air accidents, coordinated by ICAO under Annex 13 of the Convention on International Civil Aviation, stipulate that notification and participation of countries whose nationals were traveling on an aircraft involved in an accident is a requirement of all investigation processes, precisely to ensure that the families of the victims have access to the information generated by the investigation. Like, subscribe, and share. See you next time.